Hello students, welcome back into the another session of CS07 Data Structure using Programming in C. As all of you know that in our previous lecture we have completed with the most important part of data structure, that is sorting and searching. Different types of sorting techniques and different types of searching techniques we have discussed theoretically with algorithm and with programs. For some time we are skipping with the discussion of graph, as we will cover this particular section in unit number 5, that is called as tree. So right now we are starting with unit number 3, that is introduction to data structure and elementary data structure. Actually in this particular subject many topics are covered in single unit, like a theoretical part of data structure says the different types of data structure. Then it consists of the most important topic, that is called a stack. Again the most important topic called queue with their further classifications. So without wasting more time, let's fastly discuss about the basics of data structure that we are going to learn now. So we can say that yes, the actual concept of data structure starts now. As far as our subject is concerned, data structure is mainly divided into the two categories, as you can see in this particular diagram, that is linear data structure and non-linear data structure. So mainly DS, that is data structure, is divided into the two parts, linear and non-linear. Linear data structure is further divided into the four subcategories like array, stack, queue and linked list. And non-linear data type is further divided into the another four subcategories like tree, graph, table and set. Now apart from all these things, we have already discussed about array into the concept of programming in C. Even in data structure we have also discussed about various types of array. I am talking about one-dimensional array, two-dimensional array and multi-dimensional array. In this particular unit we are going to discuss about stack very shortly, then we'll go for queue and then we'll go for linked list. So whenever we finish the discussion of linked list, we can say that we are aware with the linear data structure, and after the completion of linear data structure we'll go for non-linear data structure, where we have to discuss about the tree and graph. Now let's go back into the syllabus. See why I have skipped this particular portion, that is called as graph, because it generally comes into the non-linear data structure. It is better to discuss with tree. So let's first discuss the linear type of data structure and then we can go ahead with non-linear data structure. Fine, as far as the visible difference is there, we are aware with the linear and non-linear, but what the actual difference between the linear and non-linear data structure is there. So generally into the linear data structure, data is going to be rearranged. As we know that data structure is a process for arranging the data in a different structured format. That's why the name of subject is given called data structure. So in linear data structure, data is going to be arranged into the linear format, where these linear formats are in terms of array, linked list, stack and queue. And whenever the data is rearranged into the graphical format, that means in format of tree, in format of graph, in format of table, in format of set, all that type of data structure is called as non-linear data structure. So this is a one difference, a graphical difference which bifurcates linear data structure as well as non-linear data structure. Above are the examples of linear data structure, where this is the example of stack. We'll discuss later on in detail. This is the architecture of queue. This is the architecture of linked list, and whenever the data is in format of all these things, this is tree, this is graph, this is table, and this was the set, it is called as non-linear data structure. So I hope there is a clear-cut distinction between linear and non-linear data structure. Now let's start with the stack. So first we need to go for the definition of stack. Definition of the stack. Definition of stack says that stack is a linear data structure in which data and their item is inserted and deleted one record at a time, where this entire procedure works on one procedure that is called as last in first out. That means whatever the data is inserted last should be executed first. For example, suppose in a stack we are inserting 1, then we are inserting 2, then suppose we are inserting 3. So the last data that I have inserted is 3, should be executed first. That means, again let me take the example. Suppose I am inserting 1, then 2, but this 2 is above this 1, then 3, then 4, then 5. Whenever the execution get occurs, this 5 will be executed first, then 4, then 3, then 2, and then 1. That thing is called as last in first out. Over the stack, various operation we can perform. Over here you can see our diagram which I have explained to you. Whenever we are inserting the data, it will be inserted at last. If we performs only the insertion of data, this data get raised one by one. Whenever the execution gets started, we cannot remove this data directly, as this data structure will get disturbed. So what we have to do, whatever the last data I have inserted, I have to remove the data. Then again second, then third, then fourth, and then the finally last one. So in this manner, last in first out works, which is called as stack. This stack is consist of various types of operations. So stack operations are number 1 push, number 2 pop, number 3 pip, and number 4 update. So these are the stack operations: push, pop, pip, and update. Where pip and update is similar, like push means what? This is the process to add data in a stack. Push is the process to add data in a stack. What is pop? This is the process to delete data in a stack. Pip means what? This is the process to change data in a stack. Push, pop and pip. Push is the procedure to add the data in a stack. Pop is the process to delete the data in a stack, and pip is the process to update the data in a stack. Before going, that means all these operations we have to implement practically in this entire concept. That means it contains the theoretical section, it contains the algorithm, and even it contains the program. But before this, we need to discuss one component of stack. That component of the stack is called as TOS. That is called as top of the stack. TOS means top of the stack. It's actually one pointer, or we can say one internal pointer, which manage all the above operation. All the operation means the operation called push, the operation called pop, the operation called pip. So whenever we increase top of the stack by 1, again I am repeating my words, whenever we are increasing top of the stack by 1, it perform an operation of push. Whenever we decrease the top of the stack by 1, it performs an operation of pop. Once the top of the stack, or we can say once the toss is set at a specific value, and by exchanging old value with new value, operation is called pip operation. So this is the component that we have to keep in our mind, which is called as toss. No doubt. Again, I am going to repeat the entire discussion for the second time, as this is very important. What is stack? Stack is called as one of the linear data structure. Number 1. Stack use internal memory for storing the record. Number 2. Stack works on last in first out structure. That means whatever the data comes at last is going to be executed first. Stack contains various operations. These operations are an operation of push, an operation of pop, an operation of pip, or you can say update. Push operation inserts new record, or we can say add new data in a stack. Pop will delete the last data from the stack, and pip, or you can say update, change the existing data in a stack. To perform all these operation, one component we have to keep in our mind. That component is called as top of the stack component, or in short it is called as toss. Toss is actually a one type of internal pointer which manage all the previous operations. Suppose we are increasing top of the stack by 1, then it performs the operation of push. If we decrease the top of the stack by 1, it performs the operation called pop. And once we set top of the stack at the specific position of the stack and replacing the value of the same with new, operation is called as pip, or you can say update. So this was actually the theoretical part of stack which we have to keep in our mind before the actual development procedure gets started. Now it's time to discuss about the algorithm of various functions, or we can say the operation of stack. So the first algorithm of stack which we need to discuss is an algorithm of push. So algorithm of push is written in terms of step over here. What will be the step of this algorithm? Step number 1 is one decision making statement which checks for the exception over here. That exception is called as overflow. So over here I would like to explain this exception first, and then we can go ahead. What is overflow? As this particular concept is going to be used, the concept of array, and we knows about the array that before declaring a one dimensional array we need to give the size of array. For example, generally we are writing an array like this: integer a into the bracket 10. So what does it means? A can store maximum 10 numbers. So this 10 shows the limitation of one dimensional array. Suppose I am replacing this 10 with 5. Now this particular array can store 5 numbers, any 5 numbers. Say for example I am entering 2, 0, 5, 1 and 4. Total there are 5 numbers, and suppose then I am trying to store this 9, which is actually the number 6. It shows a message of overflow as 9 cannot store inside the array because array becomes full. Already previous 5 numbers get successfully stored inside the one dimensional array. So if it happens, it shows the message of overflow and program gets written. Otherwise, every time top of the stack get increased by 1, if you remember over here, I have already written, whenever you increase the top of the stack, here instead of toss I have mentioned the word called top. Any variable name I can take. That means suppose I am increasing the value of top of the stack by 1, then I can store new value on the desired location of stack and it gets returned. So using this for function, I can store any value inside the stack. Next operation is the operation of pop. As mentioned over here, almost everything is same over here. Two things gets changed. One is the exception message. Instead of overflow, there is an underflow, and instead of this +1, there is a -1. Already I have mentioned over here, by decreasing top of the stack by 1, we can perform the operation of pop. What is underflow? Underflow means I have already stored any 5 numbers inside the one dimensional array, and I have started the operation of pop, which is also called as an operation of delete. Say for example, last value which I have stored is 2. 2 is removed, 1 is removed, 0 is removed, 6 is removed, 5 is removed. My stack is empty, and still I wish to delete something from the given stack. At that particular time, it shows an error message. That error message is an error message of underflow. Third operation is an operation of pip. Or you can say update. In this step number 1 is what? If top is equals to -1, it print underflow, and program gets written. Step number 2 is what? If item is equals to maximum of stack, it displays, that means it print overflow, and program gets terminated. That means into the case of pip, there would be the chance of underflow as well as overflow. If nothing is happened, it goes for step number 3, where on the position of stack, it search for the item which we want to replace. If this search is successful, then it replaces the position of that particular stack with the new data, or you can say the new item, and program gets written from this particular point. So this operation is called as update. Parallelly this, there should be the operation of displaying all these procedures. So the next algorithm is to display the data, where it also checks for the condition of overflow and underflow. Then it repeats step number 4 for a one loop, where from the last to the first point, as stack works in last in first out, it displays all the values of stack onto the screen, which is also called as printing the data on a screen, printing data onto the screen. So this was all about the small algorithms, or you can say various operation of stack, that is push, pop, pip and display. I think this is the sufficient dose for today's lecture. I request all the students to listen today's session at least minimum 2 times for digesting your theoretical concept of stack, because stack is very important concept as far as Saurashtra University examination is concerned, and the further topics of data structure which we are going to discuss in future. So in next lecture I am going to show a program of stack, where in single program we will develop all these operation one by one, and even we will see how can we see the output of stack. Till that, thank you very much students for listening me, and have a nice day. Before concluding the lecture, again I request all the students to listen and refer this lecture 2 times at least in a day,